Good morning, good afternoon, or good night for those of you who are doing this at midnight. Once again, it is the Trulin Rude Duo back together again.
Holla!
4.3 Linear Functions and Direct Variations. Let's take a look at a graph and see where we're going.
All right, let's point out one little thing right here. Notice we have moved to our new notation.
F of x, what is it called? Function notation.
All right, so y is bye-bye. Even though you see it right here, that was probably a mistake on my part that it should be f of x.
So we state here that we have a function called f of x equals 2x. We recognize that it has linear qualities. Y equals mx plus b, where our m is 2 and our b is 0.
All right,
So we're
there
centered
it
at the origin.
is. So, right, so a little y equals mx plus b action going on. This is my slope, and this is my y-intercept.
So quickly, if you take a look at the graph, you should be able to check that it is 2x plus 0, and indeed we start at 0, go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. And we have the rise over run feature.
All right, so it is a linear function, but it's also something new today. It's called direct
Oh
variation.
no, another term, Miss Trulin?
Yes. Direct variation means this is a linear function, so yes, it is a function. It's also direct variation because as the x values increase, so do the y values increase in a constant multiplier. Yes, there should be an L in there.
So what we're going to do, for purposes of teaching you and showing you this video, we are going to implement a strategy, and that strategy is to always follow the same pattern. It's like a formula. The formula is going to be as follows. Y equals kx, where k stands for this idea of a constant multiplier. So k is the constant. Constant meaning the term never changes. It's a number. It's usually a whole number, a fraction. It's some kind of number that's written in front of the x value.
And notice there is no y-intercept. It's got to go through 0, 0 in order for it to be direct variation. So our constant in this case is
2!
yay! So everything is constantly doubling the x value. -2 doubled to -4, -1 doubled to -2, 0 doubled to 0, 1 doubled to 2, 2 doubled to 4. And even though this is an increasing one, we can have it
decreasing such that the k value is negative. So if this was y equals -2x, we know that that would be a slope of -2 or go down 2 over 1, down 2 over 1. So it would just look different, but it would still be centered at the origin and have that constant k.
all right, so that's your direct variation. That's what we're trying to get you to understand. Y equals k of x, and even to be more better, it should be f of x equals k of x. So let's start using that f of x notation. All right, so what? Where'd this word come from?
1 to 1? Does that mean I'm like going to take 1 and add 1?
Well, we got to learn about the highest type of function. So let's kind of review some of our notes here. All right, the first thing we got to review is anytime we see the word function,
It's when the x values don't repeat. Or in other words, what is that test that we did in that last section?
oh yeah,
Had to do with function.
hey, Dylan, help me out. What's that test called?
Vertical line test.
Yes, that's right, the vertical line test. Way to come to our aid, Mr. Decker.
So we have a function is when they don't repeat. So once again, it has to pass the vertical line test, and it has to only touch our curve once.
Oh,
Next, we have 1 to 1.
Oh, that kind of makes sense now. If a function is when the x values don't repeat, a 1 to 1 means when the y values don't repeat. So function means x values don't repeat. 1 to 1 means y values don't repeat.
So if I now mix it up and I use the idea that we have 1 to 1 functions, if we mix it up, we'll say that 1 to 1 function is when what happens? Well, the x and y values won't repeat.
Right, because I have both words in that sentence there. I have 1 to 1, so the y values don't repeat, and I have the word function, so the x values don't repeat.
Not too bad, not too bad.
All right, and the last thing kind of makes sense. So if a vertical line checks to see that a graph is a function, what do you think a graph if it's a one-to-one function? Whoops, sorry, hold on there.
What do you
That's
think, Chad?
right, you use a horizontal line. So a horizontal line and a vertical line are going to check for one-to-one. So this is one-to-one.
And vertical is our function. So
And
we have two different tests here.
Right, so if you wanted to do a one-to-one function, you have to do both. All right, so
Okay, so now we have different terminology. We have function, we have one-to-one function, we have domain, and we have range. Let's go over these four main criteria that are involved in all mathematics from now until upper level.
all right. So is this a function?
Yes, it
Yes,
passes
it
that
is
vertical
a
line
function.
test.
All right. Is it a one-to-one function? Well, we already know it's a function, so let's take this puppy, let's spin it around, and let's see. Is it a one-to-one?
One-to-one, we're sliding it down. Does it pass the horizontal line test? It does.
So indeed, it is a one-to-one function.
Domain. Domain, you should recognize that the term domain means x values. So for what x values does this linear function exist?
All right, right now I'm just highlighting the easy x values, the integers, but remember the x values are anything on this x line, that's the domain. So if I put this dot in, will it eventually cross my line?
Of course.
How about this dot?
Of course.
And this dot?
Of course.
A horse, and this one, and this one, and this one, and this one, and this one. Mr. Root, is there an easy way to write that this passes every domain value possible?
Well, there are several ways. The first that we already discussed in a past video was all reals. How do we write all reals? We can just write it out in words, all reals.
Or
Another
we can do the
notation?
shortcut,
There we go.
an R with an extra back on it.
We could also use something called integral notation, which comes up a lot in upper level mathematics. So if you're going IB, AP, you'll always use the following. Negative infinity to positive infinity means you're going from leftmost to rightmost when we're dealing with the x-axis. If we're dealing with the term range, we would be doing the same idea, but we would be going along the y-axis. Range, once again, means the y values.
So does this y value go through my line? Does this y value go through my line? Does this y value go through my line? All these y values go through this lovely linear function here, so the range is...
Once again, all reals,
All
or
real.
that negative infinity to positive infinity. Interval notation. All right, so here we go with our next example. Function. Is this a function?
Gabby, is this a function?
No, it's not a function.
No, it's not a function
Once
because
again,
it
that
fails the
vertical
straight
line
line test.
One-to-one function.
Go ahead, Lindsay. Is this a one-to-one function?
Definitely not.
No, because if it's not a function, it can't be a one-to-one function.
So even though we have the term one-to-one involved with the function, you should understand one-to-one is that horizontal line test, but the term one-to-one function means it must pass both.
Okay, domain. Adam, help us out with the domain.
The domain is 0 inclusive to infinity.
Right, because the x values are here and on, so it is from 0. Inclusive means we do square brackets, and since we don't know where infinity ends, it gets round brackets.
Once again, interval notation, get in the habit of it, practice.
How about domain? How about the range, Adam? Help us out with the range.
From negative infinity to infinity.
Because the range goes from here, this will eventually hit it, this will, all those will eventually hit my graph, which opens up, and my graph, which opens up there. Okay, round 2, quick, everybody, is it a function?
Yes.
That wasn't everybody, but yes, Adam, thank you, it is a function.
Yes, it's a function.
All right, that's
You
not a
bet.
great straight line. Is it a one-to-one function?
No, Miss
No.
Truman, it is
No.
not.
It's not.
No, it fails the horizontal line test.
Touches more than once.
What a shame.
Yes, it is a shame, isn't it? All right. what is the domain? Anybody want to help out with the domain?
All reals.
All reals is right. So I'm going to take my shortcut writing my all reals that way. And what about my range? Remember my range, we look up and down.
So starting from the bottom point, let's count from the origin about
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like it hits inclusively -12.
All the way to infinity.
All the way to infinity is right.
Infinity and beyond.
Oh, we watch Pixar, don't we? All right. Ready?
Next function for a circle. Is this a function?
No.
No, it is not.
Wow, we got an
Yeah.
angry person in the back. All right, 1-to-1 function?
No.
No, because if
Ooh.
it's not a function, it can't be 1-to-1.
Automatically, domain for a circle.
All right, domain. We got to look at the x value. So domain looks this way. What's the lowest x value it hits?
-3.
Thank you, Lindsay.
Welcome.
And what's the highest x value it hits?
3.
And that's inclusive, so they get square brackets.
For our range, let's go with our range. Next.
Range goes up and down. So what's my lowest range value?
-3.
Yay! And what's my highest?
3.
Yay!
Who said the calc
We're
kids
so
were
good at
dumb?
this.
All right, thanks, guys.
You're welcome.
See you later.
Okay, so just to finish up this video, the last thing they add in this section is translations. So if you remember that, translate means to push or move a graph. So we have this graph right here, and it's a direct variation, right? It goes through 0, 0, and in fact, the original equation is y equals 2x. That's a direct variation. But if you notice over here, we have two other equations. So what we want to do is translate this red line into the purple and green line. All right, so here we go. If I take this and I drag it over, look what appears, a line. If I match that y equals 2x plus 3 right on top of each other, boom. Ah, look at that purple line. Hey, if I look at that purple line, we notice that it goes through positive 3. Remember, that's your y-intercept. And its slope is still up 2 over 1, up 2 over 1. So this red line got translated to this purple line by moving up 3. So I guess you can already guess what's going to happen to this green one. That's right, because it's a -4. We'll line them up, and it's the same exact line, except it goes through -4. And the slope is still up 2 over 1, up 2 over 1. So all three of these are still functions, because they all pass the vertical line test, and they're a translation or a push of what we call the mama function. Mama was y equals 2x. Then we had a baby, and it was y equals 2x plus 3. So all the points were just translated up 3. See, this point went up 3. 1, 2, 3. And so did every other point. And it went up on the y-axis. And then y equals 2x minus 4 is also a baby. And this baby went down 1, 2, 3, 4 from everybody from mama. All right, so what we had here was these are shifts along the y-axis. Now, you can kind of see these are shifts along the x-axis. Here's mama right here. There's mama, y equals 2x, and she had two more babies. She had the purple one and she had the green one. But they got shifted along the x-axis. See, they went left and right. Their equations can be written a little differently. If I wrote it as y equals x minus 2, all right, so I have the same line here, y equals 2x minus 4. If we apply our rules, we start at a negative 4, and then we go up 2 over 1, up 2 over 1. But another way we can look at it is this way. Notice that we've got some parentheses here. So shifts along the x-axis are noted in parentheses. And they go opposite. All right, so what does that mean? So that means this. We've got mama right here. So let's take the purple and put it on top of the red. And mama wants us to shift along the x-axis because I see parentheses. So I know that I'm going to take baby and I'm going to move it somewhere along the x-axis. But we do opposite what's in the parentheses. So since it says minus 2, everybody thinks we're going to take this purple one and go 2 along the x-axis in the minus direction, but no, we go 2 along in the positive direction. And you see, we still get the same thing. We still get a y-intercept of negative 4, and then we went up 2 over 1, up 2 over 1. All right? Let's look at the green one. Okay, the green one's a new line altogether. It's y equals 2x plus 8. Here it is going through 8, and then it's going up 2 over 1. But we could rewrite it as this. We could factor out the 2. We could look at it as a direct variation, and we could say, all right, I'm going to take this, I'm going to start it on top of mama, and I'm just going to find out where it goes by looking at shifts. So I'm along the x-axis, and I'm going to go opposite. Instead of positive 4, I'm going to go negative 4. So I'm just going to take my thing, and I'm going to move it until it is, whoops, I don't want to do that one. Let's delete him. I'm going to take this green one, and I'm going to move to negative 4. See, I took this point right here, and I went 1. Oh, this is not good. Goodbye. 2, 3, 4. Now I know it's a little confusing. They kind of throw this in the middle, but we're going to be doing a lot of these shifts as the year goes on.
Do you know if Mr. Louis has a class now?
All right, so let's try just one more. This one is asking us not to shift, but to flip. Do you remember this from geometry when you did translations on graphs? Well, remember, this is fancy for y. So they want us to negate the y. And do you remember what you do when you negate a y value? That's right. You flip over the x-axis. So if I had this right here, I'm going to take it, I'm going to clone it, and we're going to make it, let's make it green. And I'm going to take this and I'm going to flip it over the x-axis. So lovely, that means I'm going to flip this up and down. So I get this image, just like that, flipped over the x-axis. And if you're wondering where I'm going to put it, all I have to do is I say, okay, if this is a point and I flip it over the x-axis, it goes here. If this is a point and I flip it over the x-axis, it goes here. And these points that are on the x-axis, well, they don't flip because they're on the x-axis. All right, let's do the last one. Let's take this I know I'm doing it opposite here. That's the pen I picked up. How about here? This is telling us to negate the x. So when I negate the x, I flip it over. That's right, the y-axis. So let's take this graph over here. Let's clone it again. Let's change its color to red. And now I'm going to flip it left and right. And it's going over the y-axis. So it's going to look like that. That's because if I took this point right here, this is the point 2, 2, I want to negate the x, so that becomes negative 2, 2, so my new point is negative 2, 2. And that's how I do translations. But this is actually not a translation. This is a multiplier. This is called a scale. So we just want to do a little intro here because it does come into this chapter. All right. See you on Monday.